Hello everyone, today we'll talk about the solution to the problem number of ways to form a target string given a dictionary. This is a problem that's classified as hard. You also have a pretty long statement, so it might be overwhelming at first. And the key thing that you should notice to actually make this problem seem much easier, and in fact be an instance of a much easier problem, is to notice that while we have a dictionary, so we have some list of words, and we can select a word and then choose the appropriate character of that word. So to create the ith character of target, we have to get the kth character of word, and of course that makes sense. And we also have to select that word. So this is words of j of k. So this is this additional level of choice, additional level of indirection, which might be pretty difficult. But when you realize that by selecting this kth character of word, you preclude yourself from selecting the characters up to k in any possible word, then what does it even matter which word you select? The only thing that matters is that the character you select matches the character in target. It doesn't matter from which word you take it. This second part that limits your choices doesn't care about which word you've taken the letter from, only from which position. And that position is again just defined as this is the kth position you select. So that means that we can, instead of thinking of all of those words as a dictionary, we can combine them into one big word, and at every position we have some number of times a given letter available to us. So if we have, like, let's say 3 strings consisting of like A, B, C, and then 3 A's and then 3 B's, then at position 1 we have 2 A's, 1 B, and no C's. Again, we have 1 A, 2 B's, and no C's, and at position 3 we have an A B, and a C, or something like that, right? So we just can remember at every position how many times every letter appears, and we want, from a given position, exactly one letter, so there is no choice for us to make when we are looking at a given position. We can take that letter in a number of different ways, depending on the number of ways it appears in our constituent strings. And so we can simply do something similar to the longest common substring problem, where this is just a n squared dp, where we go through all the positions in the target string over all the positions in our combined word, and we try to say what is the number of ways to generate a given prefix of target using only a given prefix of our combined word. So first, the transformation from our dictionary, from the list of words, into a combined word. The combined word will be of the same length as every word in our dictionary, but instead of keeping just one letter, it keeps the counter that will give us the number of occurrences of every letter. So for every word and for every character at position I, we get one more occurrence of character at position I. So very simple. And now this counts is again the same length as every word in our dictionary separately, and it combines the information about all the words. And now, at first, we have only the prefixes of length 0 from both our words covered, and we have our function go, which will be self-recursive. Again, we have a choice at every position. Either we cover that position in the target with that position in our word, or we skip it and don't cover it. So this is a standard binary choice. Of course, we'll be using the cache decorator to make sure that this is actually a memoized DP and not just some random exponential solution. So I is the index in our combined word, j is the index in our target. If we've covered the whole target, then we're happy. There is only one way to do it because there's nothing left to be done. We return 1. Otherwise, we haven't covered our target, but we have run out of words. So we return 0. There's no way to cover the rest of the target. And now we try to cover the target by skipping that position, so that position, the combined word. So we just go with I plus 1 and j. And we can also try to cover it. And to cover it, we have to use exactly the character target of j. So what remains is that we have to cover j plus 1 with, again, starting at I plus 1. So we have covered one more character in j with the character from I. And we can do it in the number of ways. That's exactly the count of this letter want at position I in the combined word. this could be 0, and in that case nothing really happens. And the result is the sum of those two. We have to return it modulo our 10 to the 9 plus 7, and this is the whole solution. So really, if the problem immediately gave you this combined form, so it gave you essentially, here's how many times you can select, how many different versions of a given letter you can select at every position, then this would be a very short 10-line solution, and the problem would be easily a medium. And really, this one is just for you to realize by reading this complicated statement that you can combine the dictionary into a single combined word, and the rest is very standard.